Okay, this lecture we start with an example that we did previously. The manufacturer of rechargeable electric shavers wants to find an interval estimate for the mean working time of the shavers between charges. A random sample of 20 shavers has a mean of 452 minutes and a standard deviation of 9 minutes. And then we have set up a 95% confidence interval for the unknown population mean mu. Okay, so on this slide you see the 95% confidence interval for the mean working time between charges for the shavers. Now the question is, what exactly do we mean if we say that it is a 95% confidence interval? A 95% confidence interval for mu means that if we calculate the confidence interval for observed samples of the same size n from the same population, then on average 95 of every 100 such intervals will contain the unknown population parameter mu. Or if we set up a 90% confidence interval, then on average 90 of every 100 such intervals will contain the unknown population parameter mu. So let's have a look at a simulation. Okay, on this slide here I have 10 repetitions, which means that I took 10 samples from the same population and the sample sizes are all the same, 30. And then I have set up a 90% confidence interval for the unknown population mean mu from each of these samples. And then the red line that you see there on the graph is the true population mean mu. Now, if you look at the first confidence interval, the interval set up from the first sample, you can see that it does contain the red line. So the unknown population mean mu is included in that interval. That's also true for the second confidence interval, the third one, and so forth. It's only the second last confidence interval that does not contain the unknown population mean mu, so it does not contain the red line. Suppose now that we take 50 samples of size 30 and we set up confidence intervals for those 50 samples, then one would expect that 5 out of those 50 confidence intervals will not contain the red line. Okay, so you can go and count how many of these intervals, how many of these 50 intervals do not contain the red line. We expect that about 5 of them will not include the red line. If I redo this, then it might differ slightly. So it's not always exactly 5, but on average, we will expect that 5 of these intervals will not include the red line. Suppose now that I take 100 samples of size 30 and I set up a confidence level, or I use a confidence level of 0.95, then we expect that 5 out of these 100 confidence intervals will not contain the red line. Okay, so now we can say for our confidence interval, for our example, we are 95% confident that the true mean working time for shavers between charges lies between 447.8 minutes and 456.1 minutes. Okay, now the next question is, what are the factors that will influence the width of my confidence interval? So we want to have high confidence in our confidence interval, but at the same time, we would like the confidence interval to be not too wide. Now, if we go back to our confidence interval, you can see that the confidence interval, the lower limit is the sample mean minus a factor, and the upper limit is the sample mean plus that factor. So the width of the confidence interval will just be 2 times the factor. In other words, 2 times the t value times s over square root n. Now there are three factors that will influence the width of the confidence interval. First of all, we have the t-value. Now the t-value is actually a reflection of the confidence level. So the higher the confidence, the bigger the t-value and the wider the confidence interval. Then the second factor is the variation within my data, and that is reflected in S, the sample standard deviation. And then the third factor is my sample size n. Now because I divide by the square root of n, it means that the bigger my sample size, the narrower my confidence interval. Okay, so we said that there are three factors that will influence the width of my confidence interval, namely the confidence level, the standard deviation, the sample standard deviation, which is a reflection of the variation in my data, and then the sample size. So on this slide, I'm going to show you the influence of the sample size and the confidence level. So the red line that you see is the population mean, mu, and then in black we have a confidence interval. So here we have 90% confidence interval if we take a sample of size 30. So first of all, we can change the sample size and see how it will influence the width of my confidence interval. So if I decrease my sample size, then I expect my confidence interval to widen. Okay, and there you can see that the confidence interval has widened. So we have a wider confidence interval for a smaller sample size. Now we can increase our sample size. Okay, and as expected, when I increase my sample size, then the width of my confidence interval will decrease. Now the next thing is to look at the influence of the confidence level. Here I have a confidence interval for a sample of size 20 and a confidence level of 90%. So if I increase my confidence level, then we expect that the interval will become wider. Okay, and there you can see that for a 98% confidence level, my interval has become wider.